Alright, in an effort to save myself about $100, I'm going to be making a homemade, I guess if you make something it's homemade, but I'm going to be making a tachometer adapter for my car. Basically the reason why I'm doing this is I swapped out the engine in my car. It was a distributed 4-cylinder with one coil going through a distributor, had its own little igniter, and the tachometer worked off of a signal that the igniter was providing, which was the coil negative. So every time the coil would collapse, basically, I'm not going to go into the full wiring diagram, but every time the coil would collapse, that signal was sent to the so when a coil collapses, that's when it's providing a spark. So that it would send that signal, that pulse signal, to the tachometer, and the tachometer would work that way. The individual coil cars, like whether it's a 6-cylinder with 3 different coils and 2 spark plug wires coming off of each coil, that's a wasted spark setup. You can look into that. I'm not gonna describe that. You can look up what a wasted spark setup is if you want. But so if you have a wasted spark setup with 3 different coils running a 6-cylinder, then most likely, because you're not going to have a distributor and you're not going to have the igniter that's going to be providing the signal, all that's going to be coming out of the computer. So the computer that controls the car. So the signal for the tachometer will be coming from, will most likely be coming from the computer that's in the car. So there's a signal coming from that's sending a different type of pulse signal to the tachometer, and the tachometer is working that way. As RPMs go up, then pulses go up and your needle goes up. So to mimic that, since, as I said, I have individual coils on my engine now, it's a different engine. So I am going to have to use that signal that's coming off of the computer and provide a collapsing coil, which here's a coil. This is the inside of a relay. This is a H270 relay out of a Mazda MPV minivan, mid-90s. You can get these out of a junkyard. There's not a shortage of these in junkyards, actually. I don't know if it's because the van is so common or if it's just because they leak a ton of fluids, but they're in junkyards. Like every junkyard I've been in, there's been one. But this van was about to go to a junkyard, so I took the relays and fuses. And this is a relay. This is the inside of a relay. The basics of a relay is you'll have electrical current, like a small electrical current that would go through these 2 wires. That's these 2 pins from like a smaller gauge, thinner gauge wire, and it would make an electromagnet here, which pulls this little gate down, and it opens up a connection between these 2 fatter pins. The reason I'm using this relay is just because it's smashed. You can see there's a little hole in the casing. So I mean, it works, but it got a little bit crushed. So it's a good sacrifice. But if you want to buy them new, I looked them up online and they're like $7. So, and I'm sure you can find. You don't have to use this particular relay. You can use other types of relays. Yeah. So another thing that I'm using, I bought a pack of 15 transistors online. These are transistors. These are, again, if you have a different, like mine's a Toyota. The car that I'm doing this on is a Toyota. If you have a different, like say you have a Honda or you have a Nissan, I don't know if they use the coil negative, or the negative signal of the coil collapsing. I don't know if they use that to move the tachometer, but this is a transistor, and it's a 2N5551 transistor. A pack of 15 of them was $1. You can look it up online. Again, that's 2N5551. So $1 for 15 of them, free shipping. Because they just fit in an envelope, really. So shipping was cheap. And then resistors. I just need one of these. Again, it was like I think 30 that came in the pack, but. The resistors, these are rated at 1,000 ohms. An ohm is a measurement of resistance, and these are resistors. So Yeah, so this is rated at 1,000 ohms, and this is the one that is needed for my signal. I was also reading up on I think on the same web page, or it might have been another web page, where they were talking about using a potentiometer, which it's kind of like a variable resistor, if you want to think of it that way. Potentiometer is a knob. They call them pots on guitars, like, you know, your pots are dirty, meaning that, you know, as you turn it, it kind of crackles. Is usually how you would hear them talked about, but it's just the knob. As you turn it up, the resistance will go up. When you turn it back down, the resistance would go down. So when you would use the potentiometer instead of a resistor, if you wanted to fine tune and get your RPM gauge, you know, if you can't use a 1,000 ohm resistor, you have to use, I don't know, you don't know your exact resistance level that you need to use, so you can use the potentiometer to find out. Those are also pretty cheap. You would just have to find one that's rated within the correct, like, I don't know, say like 500 to 1,500 ohms, or I don't know, something that would provide you the right type of signal. What else? So resistor, transistor, relay. So yeah, I talked about, I mean, that's the only things that I'm using, and I'm going to be soldering these together. I made a rough one really quick. The same thing, but I stuck wires to these pins on the bottom, and then connected them in the order that I'm going to be doing, which is basically this little J looking thing. I guess it's like a J, but it's transistor on top, the resistor is wired in the middle, and then I had the ground on one side, and then the wires coming from the coil on the other side. But the basic wiring on this, again, I'm going to have a link to a wire diagram of what I'm talking about. But you're using the coil off the inside of this, so we're taking this little gate off, and as the positive signal goes through the coil, the circuit is going to be, as the computer, okay, well, I'm not going to explain it. I'm just going to talk about the wire diagram. I'm just going to waste time if I explain it. So there's no reason for you to understand why this is working if you can just make the same thing. If you want to understand why it works, then you can kind of read up on it on by yourself. So positive signal is going to go into one side of the coils, which on the bottom of this coil, fortunately, it actually says, bottom of the relay, it actually says coil on these two pins. These are the two that we're going to use. And I'm just going to break all this plastic off from around, and I'm going to cut these pins off because I'm not going to solder straight onto here. I'm going to solder onto the sides. So positive signal goes into one side. Out of the other side, the wire it'll be branching off after it's soldered onto here, but it's got to branch off, and it will go to the tachometer, and it will also go to this side of the transistor, which is the collector side. So it's gonna wire into the collector side of the transistor, and then between here and the relay coil, there's gonna be a wire that goes off to the tachometer. This middle pin has the resistor in line with it, and that's where you would wire the potentiometer that I'm talking about, or in this case I have the resistor wired, 1,000 ohm resistor. And then on the other side of this wire, or the other side of this little pin that's coming off of the resistor, that is going to go to my computer that is controlling the engine. So the tachometer signal is going to come out of that. It's going to go into here, and then the wire to the tachometer will go this way, positive over here, and then this remaining pin on this side is the ground. And that's the emitter. That's the emitter pin. This middle one is the base. This is the collector, as I have written out here on E, B, and C, and I just drew out a little, just so I wouldn't get confused and say the wrong thing while I'm making the video. But now I'm going to get into doing this. I'm going to try to make this as small as I can. So the reason I'm taking this gate off of the relay is because I don't want it to click every time the circuit is complete. Whenever the signal is sent from the computer, the circuit will be complete. So I get these. These are too fat. pin that back and cut that off because I don't need it. You don't want to damage the coil, so you want to kind of be careful not to damage the coil that's inside this relay. Oh cool, it popped off the table, so I don't even have to worry about moving it off the table. But I like this. I'm going to put a little piece of tape over. Actually, I'm going to do that right now, so don't forget later. Just going to put a little piece of tape over this the metal part of the coil, because I don't want the wrong pins to be connected. It's not. There we go. I don't want the wrong pins to be connected by whenever, okay, if it's like, say the pin on the transistor, like 2 pins on the transistor touch that metal that's the iron for the electromagnet in this relay. So I'm just covering that up. You don't have to do that, but yeah, it's probably recommended if you do, I guess. So that's that. I have my drill out. I'm actually gonna let me break off the plastic first. Get that out of the way. Okay. Cutting pins. I'll cut these up a little bit more later. I'm just cutting them to get them out of the way so that I can drill holes through the bottom of this, as I will actually be soldering straight onto I'll be soldering straight onto the straight onto the side of the coil where the copper wire comes off of the coil. And last one, this should be the easiest. Right. Get these out of the way. All this junk out of the way. Okay, so when I drill through this, I'm actually going to drill through just at an angle. Only reason why is so that whenever this bit actually does go through, it's not going to damage the coil. And the reason I'm doing this, I'm just drilling the holes to the bottom so that the wires will come out the bottom, and they won't be, that way I can put the cover, even though it's got a hole in it, I can put the cover over it. Straight through, didn't damage the coil, but I did push this part of that pin that's left over back to where it almost damaged the coil. If you damage the coil, you got to use another one. So now I got a nice little hole going straight through. I'm going to put a hole through the other side. Or wait, no, I don't have to put a hole through the... Yeah, I don't have to put a hole through the other side. So the positive wire is going to go up through there. Be soldered on. Brown. And I used a drill bit that was about the same size as this wire. Run that through. Shave it. If you're going to put solder on this copper wire before you bend it, or if you're before you try to solder it onto the connection, then at least bend it first, because whenever you put solder on the wire, hold on. Okay. This thing, a little soldering iron. You don't want to breathe these fumes in. This is lead, so you can read the I'm gonna hold my breath. All right. So that one's not on. I'm going to put a little dot of solder on there so that I can... Where did the solder just go? Now if you notice, there's also a resistor. If you look inside of this, there's going to be a resistor between the coil, between the two sides of the coil, the two pins. That would be to drop the voltage down to 12 volts. Breathing. I don't want to breathe this stuff in. That would be to drop the voltage down to 12 volts. There we go. Now it's on. Solid. Fold that down a little bit. Okay. So that's on. So that's one side, soldered on, nice and solid. So that's my positive wire. My positive wire is going to be this blue and black wire, which I think is old speaker wire. Doesn't really matter as long as it's for DC voltage. It's recommended to use stranded wire. It's not going to matter if it's a really small amount of stranded wire. So that's so the positive wire on this side. Before I do any more of this, I'm actually going to double check my wire diagram. Right, so on the collector side, did you notice I have this one here for reference? Collector side of the pin. What is this? I just twisted it around. How is it still stuck? What the heck? Alright. That obviously wasn't the one with the back connection from when I made it before. And this resistor and transistor, I think I'm just going to leave those there. Now I'll make them a little bit closer together. That transistor is here. So to make this, you know what, to make this simpler, I'm just going to use another. I don't want to work with that transistor. Use another one. And this resistor I'm cutting off. This is the play-by-play. Alright, so that it makes a better connection and it's not and I only have two hands. God didn't really want to give me more than two. So I'm going to twist these pins together first so that when I solder them it'll be one, easy, and two, it would be even more sturdy. So I just twisted it together, folding it over itself. That transistor is going to sit up there. sorry if I'm taking this out of the frame. I'm trying to look at it. Supposed to make it as compact as I can. Alright, so twist that together. It's time to solder. If you have the little cheap soldering irons that aren't as robust as this one, those are a pain to work with. They take a while to heat up. I don't like dealing with them. A little dot of solder. It's good if you just have a little tiny fan. You don't want a big fan, but just a fan that's blowing on your face that won't be blowing the solder pretty much into your face, so that you would breathe it in. Prolonged exposure to this stuff is, I guess, as the same thing as prolonged exposure to anything, really. Prolonged exposure to this solder is very bad on your health. Not the solder, but the lead. As breathing in the lead, people get lead poisoning, which is not a good thing. Anything that ends with poisoning is just it's not a good thing. I need a little wire, something off of this side. So turn to my drill another hole actually, because the wire is going to be going through here. Again, I don't want to damage the coil, so I'm going to angle it. Alright. Right. So that's through. And now I need another piece of tape. Man, I didn't even think about. I should have thought about that before I did it. Okay, now that little piece of tape is back. Put my wire through here. Now I'm just gonna solder one point onto this, and then I'll have another wire branching off of. I could do two. There's enough room to do two. So same thing I did last time. I'm gonna put a dot of solder. Don't like breathing that stuff in. Alright. It's gonna be easier if I just have the one solder point on here, actually. This isn't like those cooking shows where I say, this is how you do it, and then I do like 5 seconds of preparation, and then, hey look, there's one ready. Just figured I'll just go a little bit more in depth. Don't go towards my face. What the heck? Alright, so that's 2. And that little resistor between the 2 pins is still connected on the inside. If that resistor comes off, then it basically won't work at 12 volts anymore. It would be working at a different voltage. The resistor is wired in series with the coil, so it's there just to drop the voltage from whatever the coil would operate at if it doesn't have a resistor. So that puts it at 12 volts. Got that coming out. Transistor's wired on. Okay, so the collector side. So this wire is going to connect to 2 things. It's going to connect to the collector side, and it's going to go off for the signal, tachometer signal. Drill a hole in there. Actually, what I'm going to need 2 holes coming out of the bottom of this. One for the drill. So I'm going to need 1 hole going out for the ground, and the other hole will be going out for the resistor, the signal. Okay, 2 holes. So I've already got the positive wire coming out. Now I don't have a wire to, let me grab a wire to use for signal wire. Color. Got some yellow. So this is the one that's going to be going to the wait a second. Ground signal connect. Oh, actually I need a 4th hole. This thing is going to be full of holes. that is going to be the last hole that I have to drill. So this is the wire that's going to be going to there. So I'm twisting these together. This is the wire that I said was going to be going out to the tachometer. So you might want to write down your wire colors that you're going to be using after you do all this. So that. Well, it didn't even cut. Alright, so I'm double checking. The collector side is the one that I'm using here. And I don't want, actually I've got some heat shrink tubing I'm going to put around that middle pin. This is just so there's no, oh, come on. Go on. It's like I'm trying to clothe a very tiny kid. I'm going to use a larger size. This isn't working. Oh, come on. How's it that I just stuck this stuff on there and it's not even coming off? Really? Well, that's going to stay. Bigger stuff. All right. Okay, so that is around the, so now I don't have to worry about the soldering that I'm about to do to bleed over onto the resistor. This could be a lot easier, it's just that I'm making it harder by making it so contained, and Melting plastic, something else you don't want to breathe in. Get that out of the way. Have to clean the tip of my thing now. I'm trying to cram too much in this little pocket. So what else can I do? If I can, let's do that. That works. Still a connection, it just looks a little messy. Just bent the transistor all the way around to where it'll still work. Yeah. Sorry if this video is taking so long. Alright. So that's going to be good. I can solder that on. And I'll have this little pin sticking out the bottom that I'll solder a wire onto. And the remaining one is this ground wire that's on the emitter side. So I'm just going to twist this around and solder it now so that I don't have to later. It's so hard working with this stuff. It's so tiny. Which side was the... Now that I folded it around, I don't know which side was the ground. This side. That will do. That will do, donkey. That will do. It's a Shrek reference, by the way. Just so I don't sound crazy. Alright, is that on the right side? Yes, it is. Hopefully this thing will still work good after I just melt the plastic with it. I don't want plastic. I don't know if plastic is still stuck on the tip of this. So that's good. That's in place. Nice and solid. Now finally, feed this through one of the holes that I made. And I will be able to solder this now on this side. Wow. Okay. Last bit of soldering, with the exception of that pin that's hanging out of the bottom. Alright, so made it like I wanted to make it. And that fits over it fine. Looks like everything's soldered together good. A little ground wire here. I want to get it away from that stuff. Now all that's left to do is solder another wire here. So you have to remember that it's like, well, actually that worked out perfectly because I have the positive and I have a negative here beside each other, and this is going to be a switched positive. And then here That's the signal coming out of the car's computer, controlling the engine, and this is going to the tachometer. So I just have to do one final wire on the bottom. It's that one. And since that's exposed, I'm going to put some heat shrink around it. Sorry, I had to get another wire. Alright. Same thing. I'm just going to twist these together. Get these other wires out of the way. Hopefully, if you're doing this, hopefully you tested this relay before. I tested mine, so I know that it works. And the way you'll know that it works, you'll hear it click. So whenever you connect a positive and a negative wire to the two coil pins that were on the bottom here, you'll hear it click. And that click is that electromagnet actuating the little gate. If you don't have heat shrink tubing, you can use electrical tape, but you should actually use heat shrink tubing when you can. I like this clear stuff that I have. It's pretty good. Because I can see it, I can see to the inside and make sure if I'm testing a connection. And this, I love this little torch. I think it's the coolest torch. Based off of the Beretta. So cool. So that's it. I have my two signal wires here, one from the computer and one to the computer. Or I guess I should say one to the tachometer and one to the computer. And that's it. I can put the cover on for the relay. And I'm gonna take the paint off here so it won't be showing that it's a H270 relay anymore, because that's not what it is anymore. Well, that's what it is. A little piece of metal still in the way. Alright. That should be better. that's it. A nice little consolidator. I got the wires coming out of it. And you look at this thing and you think, what is that? If you don't know what it is. But that's it. So I have my positive, which is blue and black. I have my negative, which is the black. And then I have my, what is this one? Gray, and the black one was going to the computer for the signal. And this one was going to the tachometer for the signal. So this should work. I will post up a comment if it doesn't. But this is the same thing as that wire diagram that I have linked in my description. Yeah. So thanks for watching, and subscribe, I guess, if I do some stuff like this randomly. Most of my stuff is car repair or whatever else, but subscribe if you want, click like if you liked, or don't subscribe or don't like if you didn't. Thanks a lot.